So we will discuss sets. Now, we all know that a set is a collection of objects, where the objects are what we call the elements of a given set. Now, to describe a given set, we can use open and close brace, and then we have X, such that any given statement P about X is true. Now, we have some types of sets. First, we have a subset. So a subset is simply a part of a given set. Second, we also have equal sets. So equal sets, how do we know if they are equal? Um, if they have precisely the same elements. And then we have three equivalent set, or equivalent sets. Equivalent sets, how do we know if they are equivalent? If they have the same number of elements. So let's have some notations. So we describe a set, or we denote a given set by using any big letter. Now, for the elements of a given set, we denote it by any small letter. So if we say that a given element is or belongs to a given set, we write it as this. So we read A is an element of A. So A is the element, A is the set. What about if A is not an element of a given set? So we write it as this. So A is not an element of A. What about if we have a set that is a subset of a given set? So we write it as this. So A, then this symbol, then B. So it means that A is a subset of B. If A is not a subset of B, we write it this way. So A is not a subset of B. If A and B are equal sets, we write it as this. So A and then equals B. So A is equal to B. If A is equivalent to B, we write it this way. A and then this symbol, then B. So A is equivalent to B. So there are also some sets that I did not define, so I will write it here. So the first one we have omega, which is the universal set. So the universal set, simply the totality of all elements. And then we also have this symbol, which is the empty set. So the empty set is the set that has no elements. So we also have the power set. So we denote it like this. So the power set of the set X. So it means that it is the set of all possible subsets of X. Now, to determine the set of all possible subsets of X, it is simply 2 to the 2 to the X. So 2 to the absolute value of X, where absolute value of X be the cardinality of the set X. Cardinality meaning the number of elements in a given set. So for example, if we have X be the set which has elements A and B, so the power set of X would be 2 to the cardinality of X is 2. So we have 4 possible subsets. So what are those? We have the empty, the set X, the set containing A, and the set containing B. So in sets, we also have operations. So we have 4 operations in sets, namely union, intersection, the complement, and the difference. So if we have 2 sets A and B, so we define the union be this way. So A union B. So it is the set of X such that X element of A or X element of B For intersection, we write it this way. So it is the set X such that X element of A and X element of B for the complement. If we have a set A and you need to get its complement, so it is simply the set X element of the universal set such that X is not an element of A. And then for the difference A minus B, we have X, the set of X such that X element of A and X not an element of B. So let's have sets of numbers. So the first set of number would be the set containing 0. And then next comes n. So n is the set of natural numbers. Or the set of counting numbers. Next we have z. So z is the set of integers. And then we also have q. Q is the set of rational numbers. And then we have r, the set of real numbers. And lastly, we have c. So c is the set of complex numbers. So we all know that the natural numbers or the counting numbers are the numbers 1, 2, 3, 4, 5, 6, and so on and so forth. So we have the numbers to count. Then for the integers, so these are the numbers negative 1, negative 2. So the negative numbers, also the positive numbers. So other books include the number 0 in the set of integers, but others don't. So here we will not include the number 0 in the set of integers. Then next we have the set of rational numbers. So we all know that a rational number is a ratio of two integers. And then we have R, the set of real numbers. So a real number is a number that can be found in a so-called real number line. And lastly, we have the set of complex numbers. So the set of complex numbers are of the form a plus bi. So such that a and b be elements of the set of real numbers. And there is another definition that if we take I squared, so I is here, so if we take this I square, so the result would be minus 1. So basically we have the set containing 0, and then after that uh, it includes the integers. So the integers has two parts. We have z minus and z plus. Z plus pertains to the set of positive integers, while z minus pertains to the set of negative integers. And then after the integers, we have q. So and then after q, we have r. Now in r, we include q complement, meaning this is the set of irrational numbers. So those numbers that are not rational. By the way, z plus here also pertains to n, so the set of natural numbers. And then lastly, we have c. So this is the hierarchy of the set of numbers. So for the last topic, I will connect set to logic. I already introduced to you the notation for subset. So A is a subset of B, where in any element, or if we have an element that contains in A, it must also contains in B. So in logic, so I will use this symbol. So it reads if and only if. So IFF. So we say that A is a subset of B if and only if X element of A implies X element of B for all X element of A. So to prove that a set is a subset of another set, we must show that given an arbitrary X that is an element of A must also an element of B. Now, for equality of two sets A and B, so to prove that A is equal to B, we must show that A is a subset of B and B is a subset of A. So if this statement happens to be true, so we must say that the two sets are equal.